Well, this week we begin looking at selection statements and Boolean type variables. If you remember, we've talked about the 8 different built-in primitive type variables, the 4 integer types, the 2 decimal types, the character, and Boolean is the last of the primitive data types. So we'll look at the Boolean data type as well as how we can write programs that select what statements we want to execute. Well, the selection construct is the second programming construct that I've mentioned before. We have been using the sequence construct only by itself in the programs we have wrote in chapters 1 and chapters 2. We simply executed one instruction after another. Now we can take a look at the selection construct. And in the selection construct, we are going to be able to choose what instructions we execute. And we'll move on in chapter 4 to iteration or looping construct. And that these 3 constructs, the way we put those together in combination with each other, can make some very powerful programs. Alright, so this lesson we'll look at the Boolean data type. We'll learn about how to write Boolean expressions. So where an arithmetic expression returns a numeric value, a Boolean expression is going to either return true or false. We'll look at the arithmetic quiz as presented in the book, right? And listing 3.1. And there's a supplemental video that goes through and explains very well step by step what's happening in that program. Okay. We'll look at implementing one-way, what we call a one-way selection statement, a simple if statement. And then we'll kind of introduce a program called the Guess Birthday Game. Appendix A, you should find true and false are in there as reserved words. Well, oftentimes we want to know or understand the relationship between 2 items, 2 variables. Is one greater than the other? Is one equal to the other? Etc. Right? In order to do that, we need to have a mechanism to create a what is termed a Boolean expression. And a Boolean expression always returns a value of either true or false. Consequently, we need a new data type, a data type that can hold only the value of true or false. And so that data type is Boolean. If we look at the example where we are initializing B, right, and the Boolean B to what is returned by the Boolean expression 1 greater than 2. What would be returned? Is 1 greater than 2? If it is, B will be true. If it's not, B will be false. Understand that the greater than sign is known as a relational operator. And on the next slide, we will take a look at the various relational operators. They're fairly simple to understand. You probably came across most of these in an algebra course someplace. Also, it is important to remember that the Boolean value is either true or false. So if I had another Boolean variable, let's call it minor, and I could set that value, I want to initialize that value to true or false, I have to use the lowercase true or the lowercase false, because those are the values that are recognized, and Java is case sensitive. If you look up your reserved words in depending on how a problem is worded, you need to determine whether you're going to use the less than or equal, or simply the less than, or the greater than, or the greater than or equal. Okay? Whenever a problem states that we are looking for a range that includes both ends, or includes an end, such as we're looking for the numbers between 1 and 1,000 inclusive, that means that we are going to be looking for a number that is greater than or equal to 1, and it's less than or equal to 1,000 because it was inclusive. So you have to pay attention to the wording. Well, from a elementary freshman algebra course, your operators here should be pretty self-explanatory. You probably have used most of these operators at one time or another in algebra, right? There are two special operators that you may not recognize. One is the equal to, and notice that's the double equal. And so that's to distinguish it between the single equal sign, which is an assignment operator. So it is a very common mistake when we're writing a Boolean expression for equality that we forget and use simply a single equal sign. So something like 5 equals 7 will be very unintelligible and probably throw a compile error. Right? So remember that as far as the Boolean operators are concerned, you use the double equal sign to test for equality. And the last, not equal, right, uses the exclamation point and an equal sign simply to test for inequality. We're not concerned if it's less than or greater than, or we're simply concerned about that it is not equal. Okay? Okay, we've been given this task to write a arithmetic addition quiz or practice program for we'll say first or second graders. So the idea is that we want our program to generate 2 random numbers to start, and then we'll ask the user somehow what is the sum of these 2 numbers. So if we generate 7 and 9 as the numbers, we might ask a question, what is 7 plus 9? And then we'll get the answer from the user. So once we have an answer, then we can test, right, as to whether the answer is right or wrong. And so if we're going to check for something that's right or wrong, we're really going to need a Boolean of some sort, because we're basically testing to see if their answer is true or false. All right? And then we have to tell the user what the result was. whether they were correct or what the correct answer is. So be sure to watch the additional video on the addition quiz as the author explains how he has implemented this pseudocode. Always remember, if you can read the pseudocode, if you can create the pseudocode, you should be able to, at this point, start creating your programs. All right, let's introduce the simple if statement, sometimes called the one-way if statement. All right, the syntax of the if statement appears on your upper left here. You have if, and then you have some Boolean expression in parentheses, and that's important, right? So you have that Boolean expression in parentheses, and that is going to equate or evaluate to either a true or false. And then you have a brace to open up a block of code and a closing brace. So the braces, in this case, enclose the statements that will be executed if the Boolean expression is true. Right? So in this case, the statements following the braces here are only executed if the statements are true, if the Boolean expression is true. Suppose we look back at that compute area program that was introduced back in chapter 1, I believe, maybe chapter 2. Right? We did not take into account that the user may enter a negative number. If you're doing a get input from the keyboard, a negative number is simply entered by putting a minus sign in front of it. Well, we can't compute the area of a circle with a minus radius, a negative radius. So we could have implemented a Boolean statement, an if statement, right? In which, in this case, the Boolean expression is checking to make sure that the radius is greater than or equal to 0. So we're assuming radius was entered by the user. If that is true, then the statements, and in this case there are two statements following the open brace, right? So that's a code block. The first statement computes the area, and the second statement outputs the message of what resulted in the area. Right? From a style standpoint, notice that the statements enclosed by the code block braces are indented, so it makes it a little easier to read. Okay. At the bottom of the slide, you see these are what we call flowchart symbols, and so a diamond is used to represent a Boolean expression or an if statement, and it has two branches that come out of it. In this case, it has a false branch, right? Because if radius is less than 0, right, we're going to take the false branch, and if it's greater than or equal to 0, we're going to take the true branch, and we're going to compute the area, right? So, the question is, right, what happens in this case where the Boolean expression is false? And what happens is the statements in the code block that you see, where we compute the area and display the message, are not executed. And the program continues execution with the statement that follows the closing brace of the code block. So the right-hand part of the flowchart here kind of shows that. It shows that if radius greater than 0 is false, then it skips over all of those statements, or all of them too, right? That's in the code block, and continues executing with whatever statements follow that. And the code snippet up there regarding if radius greater than 0 also demonstrates how we can take two of our programming constructs, the selection construct and the sequence construct, and put them together. Of course, the if statement is the selection construct. And if we're true, if the if is true, then the statements in the code block, computing the area and displaying the message, are executed as in a sequence run after another. So here we have a case of combining a selection statement and a sequence construct together. And we'll see more of that. Well, this slide demonstrates a couple of things. If we look at the A side, the left, right? It says that the first statement there is wrong. Let's study it. What is wrong? Well, what is wrong is that the Boolean expression 1 greater than 0 was not enclosed in parentheses. So that's what the error is, okay? So B is the correct syntax, all right? The second example, right, shows that the Boolean expression being tested, and if it's true, all right, we have the opening brace and the closing brace for the code block, and that's what we learned earlier. But it says, hey, under column B on that second example, that is equivalent. That is also a valid statement also. The rule is if you only have one statement that will be executed as part of the code block, you don't need to put the code block braces around it. My suggestion is always use the braces. Then you won't have to be asking yourself, do I use the brace this time or do I not use the braces? If you always get in the habit of using the braces for delimiting the code block, you can be safe. Okay, we have a problem here that will allow us to demonstrate the use of the simple if or the one-way if statement. And the problem is we're going to have to ask the user to enter a number, and then we'll have to determine if that number is divisible by 5 or divisible by 2. So the first question you should be asking yourself, if it's not obvious, is how do I know if a number is divisible by 5 or 2? Well, if we're going to need to determine if a number is divisible by 5 or 2, we can do that with the modulus operator, or the percent sign. If the modulus operator returns a value of 0 when we use 5, or a 0 when we use 2, then we know that the number is divisible by 5 or 2. So the next slide, we'll work out the pseudocode for this problem. Okay, let's take a look at the pseudocode for solving our little problem here. We need to ask the user to enter an integer, and once that integer is entered, we need to test to see if it's divisible by 5 using the remainder operator. And then if it is, we'll display the message high 5. And we'll go on to the next test to see if it's divisible by 2. And display the message high even if it's divisible by 2. Now remember, the remainder operator will return 0 if it's evenly divisible by 5 or evenly divisible by 2. Okay? And a number can be both divisible by 5 and divisible by 2. The number 10, for example, or 20. So here's the code that implements our pseudocode. The first part of this should be pretty familiar to you by now. The new parts are down there where we do the test. The first test is for divisible by 5. And in the brackets after the if, that's our Boolean expression. We do number %5, so that's taking the number that was entered, dividing it by 5 to give the remainder. And if that's 0, then the Boolean expression is true, and the next statement in the code block will be executed. We have the same type of test following that for the number divisible by 2. It will return a 0, and we'll have that code block executed only if it's true. So that's the program. The only other thing to highlight here is notice by convention I've used the braces for the code block on each of the if statements, even though there's only one statement. I think it's good practice to do this. Otherwise you might forget the braces when you have multiple statements. So it's good practice to use the brackets to enclose your code block. We're switching gears right now just to do a little bit of review of binary and how binary works. Remember, binary is base 2, and the positions from right to left in binary represent the number 2 to the power. 2 to the 0, 2 to the first, and so on. At this point, you can see what the individual positions, what value the individual positions represent. They're simply powers of 2. Start from the right and continually multiply by 2. So 2 times 1 is 2, 2 times 2 is 4, etc., etc. So these are the decimal positions represented by each of the locations. Now, in order to find a decimal value for this binary number, we are only concerned about the positions that have a 1 in the binary number. And so we would take 1 times 0, and that would give us a 1. And 1 times 2 to the first, and that would give me 2. And 1 times 2 to the second, and that gives me 4. So notice that as we start building our chain here and adding these numbers up, that we have 0 in position 2 to the third, and we have 0 in the position 2 to the 6th, so we don't add those numbers in. So adding our decimal values together, we have a sum of 183, and so our binary number, reading from left to right, 10110111, is equivalent to 183 in decimal. Now, why are we doing this little review? Well, we're going to, the next section talks about a guessing game where you can ask the user 5 questions, and you can tell the user then what day their birthday is. And in order to do this, we have to think about, all right, the number of days in a month, and the most the number of days in a month can be is 31. So we're going to need 5 binary numbers to come up with 31, from 2 to the 0 to 2 to the 4th. So if we look at their values, we have 16, 8, 4, 2, and 1. Adding them together, 16 plus 8 is 24, plus 8 is 28, plus 2 is 30, plus 1 is 31. So those 4 numbers, any combination of those 4 binary numbers, will give us a value between 1 and 31, in which case somebody's birthday has to be in the value between 1 and 31. So let's take a look at the next slide. So here's the 5 sets of numbers we're going to present to the user, and each time we present a set of numbers, we will ask the user if their birthday is in that set. Now, these sets of numbers have been constructed very carefully, right? So if you notice that the first number in the set represents a power of 2. So in the first set 1, the first number is 1, and that's 2 to the 0. And in set 2, the first number is 2, and that's 2 to the first. And you can see 2 to the second, 2 to the third, and 2 to the fourth. So all the first numbers represent that power of 2. Now, the rest of the numbers in the block, right, also are very carefully constructed, in that, 2 to the 0, for example, means that there is a 1 in that position, binary. And if we look at the number 3 in set 1, there's a 1 in the 0 position. And the same with 5. There's a 1 in the 0 position to represent 5. So all of the numbers in the block have a 1 in that position. Right? Block 2. All right? That means there's a 1 in the second position. Well, we have a 3. There has to be a 1 there, because I need 2 to the 0 and 2 to the first to make 3. Right? So the blocks have been very carefully selected and constructed, all right, to represent where we might have a 1 in a particular position. So, for example, now, if the user's birthday is the 19th of the month, they will say yes to block 1, yes to block 2, no to 3, no to 4, and yes to 5. So in that case, I simply need to add 1, 2, and 16 to come up with that your birthday is on the 19th of the month. Try it for your birthday. Is your birthday in block 1? Is it in block 2? Is it in block 3? Is it in block 4? Is it in block 5? Well, for each block where you answered yes, take the first number in that block and add it. Add them all together. So that's kind of the gist of the problem we'll be looking at next time for section 3.5.
Huh?